This is a story of molten rock, wind and fire, of creation and destruction. It is the story of the astonishing forces that repeatedly reshape our world. They work together, are mutually dependent, and enhance each other. Scientists are working to understand these interrelationships so that we can be better protected. Because if the Earth were an apple, its crust would be no thicker than the skin, and on it, we erect skyscrapers and settle in the shadow of fire-spitting mountains. Volcanoes, earthquakes, and storms, they'll be with us always. So we have to protect ourselves from their violent tempers. Because although its beauty is incomparable, our wild planet is no gentle giant. In North Kivu in the Democratic Republic of the Congo, closed to the public so to speak, sees a volcano like no other. Mount Nyiragongo soars to a height of 3,500 meters. Its crater measures 1,000 meters in diameter. The international expedition team here, setting out to explore the volcano, will be the last for an indefinite period of time to make the descent into the steamy depths. 400 meters deep boils one of 5 lava lakes worldwide. This is the largest of them all. For over 17 years, Italian volcanologist Dario Tedesco has monitored the volcano on a UN contract. It commands his greatest respect.
Mount Nyiragongo is probably the volcano that emits more sulfur dioxide in the world. In 2005, it was measured around 70,000 tons per day, which more or less is what all volcanoes around the world emitted in one day. Nyiragongo does it alone. And it's the amount of all the sulfur dioxide emitted by all industries, if you want, more or less in Europe.
The descent is risky business because the walls of the crater are worn down and brittle from the sulfur dioxide. The plan is to take fresh lava samples from the bubbling molten flow. The gases in the lava contain vital information about the state of the volcano. Halfway down, the men will stop and spend the night. The next morning, they will lower themselves to the banks of the lava lake. In the dark of night, the pulsating glow of the 1,000 degrees Celsius hot lava is even more dramatic to behold, at once mesmerizing and terrifying. In creating breathing space and releasing inner pressure, our Earth stages natural spectacles of astounding beauty. But how do volcanoes actually work? What fuels them? Let's hazard a look into the witch's cauldron of our planet. After penetrating the Earth's crust, we plunge down about 100 kilometers into the depths, into a zone called the asthenosphere. At this level, temperatures of up to 1,200 degrees Celsius liquefy the rock. When the molten rock reaches the underbelly of the Earth's crust, it pushes its way upwards, filling cracks and cavities. As soon as the magma reaches the Earth's surface, its name changes to lava. The Nyiragongo lava is alkaline and thus especially fluid, which means that in an eruption, it wouldn't shoot up explosively. It would simply overflow and race off towards the valley below.
is the quickest lava flows in the world, 100 kilometers per hour. It means that if you are in front of this lava flow, you cannot escape. You cannot running away. It's faster than you.
The last eruption, January 2002. More than 22 million cubic meters of red-hot molten lava pour into the metropolis Goma, killing 100 and sending 500,000 fleeing for safety. The scientists must repeatedly risk the journey down to the edge of the lava lake so that they'll be able to warn people of the next eruption in time. But what the man here in the silver thermal suit is planning to do now goes way beyond the usual protocols.
It is dangerous in my opinion. It is a little crazy. I mean, I won't do that.
Dario knows whereof he speaks. The lava expands and contracts, rises and sinks without warning. Within minutes, levels can change by more than a meter.
It's just on the rim. It's crazy.
Don't stay so long. That's already 5 minutes. It's very dangerous.
At the last minute, the daredevil researcher manages to move away just before the lava again boils over.
Very strong, exactly where he was.
He needn't have put his life on the line. He could have just taken a sample from the overflow. But the pulsating lava emanates an almost magnetic force of attraction, tempting even serious scientists into taking reckless risks. But how do volcanoes come to be, and what fuels them? Like pearls on a string, most volcanoes line up along the borders of the plates that divide up the crust of the Earth. At the edge of the continental plates, the oceanic plates are pushed beneath them, as if on an assembly line. New crust is reformed along the oceanic ridges, and the old cooled-down plates disappear as they are submerged beneath the continental plates. The cycle is complete. Wherever liquid rock drills through the Earth's crust, volcanoes arise. Around 1,900 volcanoes worldwide are considered active today. We're more or less surrounded by them. The southernmost of them lies on Ross Island in the Antarctic, Mount Erebus. Like Mount Nyiragongo, it too has a lava lake within, making it highly attractive for volcanologists. They first have to spend a few days here at a very bare bones base, getting acclimatized. A few tents, an outhouse, that's it. Only then may they proceed to the little research station, which has been used since the 1970s to monitor Mount Erebus. The average summer temperature is minus 20 degrees Celsius, and the wind blows constantly. 2 helicopters crashed here due to the strong winds and thin, high-altitude air. Luckily, all passengers survived. The destination of the expedition is only an hour's hike away. The scientists use the ascent to start gathering samples of the lava that the volcano now and again spits out. The samples are dated for analysis upon return to Cambridge University. One of the key goals of every volcanologist is accurate eruption forecasting. To achieve this, it is vital to understand how volcanoes work, what fuels them, how they erupt, and why. Mount Erebus, with its lava lake, is a perfect study specimen. British volcanologist Clive Oppenheimer uses an infrared spectroscope to measure, second for second, the gases that escape the volcano. The extreme aridity way up here makes it easy for him to measure the steam exhaled by the volcano. This would be impossible at more humid locations, such as Mount Nyiragongo.
What makes Erebus unique and worth traveling such a long way to reach is it's continuously active and has a lava lake in the summit crater. The lava composition is a magma type called phonolite, and Erebus is the only currently active phonolite volcano in the world. And yet it's a very important magma type because it's fueled some of the most violent eruptions of history and prehistory. The famous Vesuvius in Italy, for example, is a phonolite volcano. So if we want to study how phonolite volcanoes work and erupt, this is a great natural laboratory to do it.
But Erebus too can be dangerous, throwing lava bombs of up to 3 meters in diameter. Most treacherous, though, are the sudden weather changes. When the wind sweeps over the crater's edge, even the best measuring devices are blinded. What the scientists find out here can help them make life in the neighborhood of volcanoes safer the world over. Far from the polar ice, just 20 kilometers from Goma, the lava lake of Mount Nyiragongo seethes on. Deep underground, the earth here is marbled with fissures through which the magma pushes upwards. No one can say when it will next breach the surface. But the lava lake itself is not the problem. When Nyiragongo erupted in 2002, the lava shot out in the direction of Goma from cracks in its sides. The deadly swath from back then has long been built over, although the next eruption will most likely take the same path. Thousands of new huts now stand on the cold, hardened lava. Soldiers everywhere. For over 20 years now, the country has been engaged in hostilities. Darius's project, supported by the European Union and DDC Swiss Corporation, is constantly at risk.
At the moment, both the Volcano Observatory and us cannot go outside the city. We cannot work on the volcano. To avoid any loss of material, we repatriated all the station inside the observatory. This means simply, in a simple word, that we are blind compared to the activity of the volcano.
And as if that weren't enough, the residents of Goma face yet another threat. The city lies on the shore of Lake Kivu. Huge amounts of carbon dioxide and methane reserves are dissolved in its deep waters. The last time Mount Nyiragongo erupted, the lava flow made it all the way into the lake, but did not reach the deep waters. If the next eruption were to bring larger amounts to the deeper parts of the lake, a catastrophe would be certain. German physicist Klaus Tietze has been studying the lake for 40 years now. Tietze first came to Lake Kivu in 1974. With the help of self-developed measuring and sampling systems, he began to systematically analyze the lake and its dangerous gas secret. Since then, Kivu has held him in its thrall.
Lake Kivu's like a medallion. It has 2 sides. One of them is gorgeous, marvelous, stunning to behold, and made of gold. The 60 billion cubic meters of methane there is valued at around 20 billion euros. The other side bears a grim face. If the lake were to explode, up to 3 million people could die.
The physicist has been working for decades to prevent this from happening and to help exploit the lake's riches via a special degassing procedure. The aim is to extract the methane and the carbon dioxide to generate electricity and to prevent explosion. In 1986, at Lake Nyos in Cameroon, the very thing happened that Tietze persistently warns of at Kivu. Like a champagne bottle when the cork pops, nearly pure carbon dioxide erupted from the lake. A several meter-thick deadly gas cloud, odorless and colorless, flowed down the adjacent valleys, offering no chance of survival. Over 3,500 animals and almost 2,000 people met their death by asphyxiation. An army of scientists from across the globe descended on the deadly lake. Klaus Tietze was among them. He again proceeded with his systematic measurements and was the first to reconstruct the causes and mechanisms of the disaster. Lake Kivu, however, is many times larger than Lake Nyos, and here millions of human lives are at stake. In 2006, construction began on a gas extraction plant using the Tietze method. However, disputes with the Rwandan government led to withdrawing himself from the project. Meanwhile, Tietze has developed a clean concept for carbon dioxide utilization.
I'm convinced that I've succeeded in developing a method that transforms carbon dioxide economically into a valuable resource. So instead of 20, you could get 40 billion euros out of the lake to do more for the people there. Eventually, it would make the lake completely safe, because the carbon dioxide wouldn't have to be returned to the lake or pollute the atmosphere. The lake would be free of gases. There'd be no danger when a volcano spits into it. This method can also be a model for solving the worldwide carbon dioxide problem.
But will Tietze be able to degas the lake in time and actually bring wealth to the region? Given the current political situation, it's doubtful at best. More than half of all recently active volcanoes are lined up in formation around the edge of the Pacific Basin, the Ring of Fire. Almost everywhere, there is human habitation nearby. For those living in their shadow, volcanoes are both a blessing and a curse. The people are dependent on them, yet fear their angry outbursts. In the east of the Indonesian island of Java lies Mount Bromo. Named after the Hindu god Brahma, it neighbors Mount Merapi, the island's best-known active volcano. The fertile volcanic soil and mild tropical climate bestow up to 4 harvests a year on the local farmers. For this reason, Java has become the most densely populated island in the world. At sunrise, the slopes of Mount Bromo are often covered in a thick fog layer. It is the hour of pilgrimage. A temple stands at the foot of the volcano. The pilgrimage route begins here. Every year, thousands of the faithful gather at the crater's edge to make offerings on the occasion of the Kasada festival. 241 steps lead high up to the edge of the crater. Up at the top, the worshippers are already awaited by the poorest of the poor, who have taken up post within the crater to catch the offerings as they're thrown in. Rice balls, fruit, vegetables, small animals, and sometimes even live goats are snatched from under the noses of the gods. Mount Merapi is more dangerous. Its last major eruption in 2010 sent an 800 degrees Celsius molten avalanche of ash, rocks, boulders, and hot gases, known as pyroclastic flow, into the valley. It killed hundreds of people and destroyed 18 villages, leaving in its wake scorched earth and crushed homes under a centimeter-thick layer of gray ash. After the disaster, the almost 300,000 evacuees returned to their villages to find that all life in their former garden paradise had been extinguished. But the people resettled there nonetheless, rebuilding their huts and houses. They used the volcanic mud from the rivers and streams as building material. But it's hazardous work. At any moment, a lahar, a swift volcanic mud flow, could roll through the valley. These follow-up disasters routinely consume entire villages, sending the villagers again running for cover. In the far east of the island lies the crater lake Kawaiʻien, the world's biggest acid barrel. Its water has a pH of 0.3, almost as acidic as battery acid. On the southeast shore of the lake lies the most active solfataras on Earth. Here, sulfurous gas, at temperatures of up to 450 degrees Celsius, are released. The sulfurous fumes are fed through a water-cooled pipe system to the tapping point, where the sulfur comes to light as a gooey reddish mass. Only when completely cooled does it attain its signature fluorescent yellow color. 365 days a year, the sulfur miners risk their lives and health. But the hazardous work earns them 4 times what the local farmers do. So for the miners, the volcano means progress. On the island of Matupi in Papua New Guinea, however, a volcano has catapulted human civilization back to the Stone Age. Since 19 years, the Tarvurvur has belched clouds of ash. The once fertile volcanic island is now parched, the rain is acidic, and most plant life has suffocated. Yet many inhabitants hold out here, mainly because they just can't afford to resettle. The people's only companions are Melanesian megapode, or so-called thermometer chickens. Their beaks have a very sensitive sense of temperature, normally used to monitor nest temperature. They have adapted to life on the volcano and no longer brood their own eggs. They just bury them, and the heat of the volcano does the rest. Because there is nothing to harvest from the parched earth, food prices here are twice as high as in the rest of the country. The only edibles the locals produce themselves are the precious eggs of the thermometer chickens. These men are doing death-defying work. At irregular intervals, the volcano spits out red-hot lava bombs that can be deadly. And its toxic gases concentrate near the ground. More than once, men have been poisoned or asphyxiated while digging, but they keep returning nonetheless. The Tarvurvur shows more clearly than anywhere else on Earth how small we are compared to the untamed powers of the volcanoes. But the fire-spitting peaks can also cause trouble in Europe. In the spring of 2010, Iceland's Eyjafjallajökull sent its ash shooting kilometers up into the sky. The outbreak was not particularly intense, but it occurred beneath a glacier. The exploding lava hit the meltwater, tearing the ash into tiny little bits. Sucked up by airplane turbines, this ash particulate can clog them and hamper movement. Mandatory flight groundings cost hundreds of millions of euros a day. Once a month, the Lufthansa Airbus Leverkusen has a turnaround at Frankfurt Airport for more than just exchanging luggage, cleaning the seats, refueling, and updating the menus. Unbeknownst to the passengers on these flights, they are taking part in a scientific expedition. The long-haul jet has been converted for an international research project. 12 scientific institutes worldwide are cooperating on the mammoth project called Caribik. Scientists and engineers from the Max Planck Institute for Chemistry in nearby Mainz arrive at the airport with the centerpiece of the study, a 1.5-ton container. Once in the cargo deck, the container, filled to bursting with technology, is connected to the intake system on the underbelly of the airplane. The devices measure more than 40 climate-relevant trace gases, as well as steam and fine particles suspended in the atmosphere. Since 2004, air is sucked in on a long-haul flight between the departure and destination airports. The samples are compared to meteorological maps to chart the sources of impurities and how the atmosphere purifies itself. Karl Brennigmeyer, the head of the project, has already sent the measurement container on a journey of more than 2 million kilometers around the world, analyzing thousands of air samples.
When a volcanic eruption reaches the stratosphere and the ash particles and oxidized sulfur components cool the atmosphere down, we have to determine precisely how long the volcanic ash particles remain in the atmosphere, where they're transported to, which gases in what amounts play a role. And that's exactly the data we're gathering with the Caribic measurements. This information flows into models that enable us to make predictions about future climate change on Earth.
Karl Brennigmeyer's project also registers key human interventions, including traffic and transportation, heating and factories, and the exhaust fumes of the burgeoning Asian megacities. And the ash particles also absorb light and block a portion of the sun's rays from reaching the Earth's surface. It gets cooler. But the effect is short-term. However, tons of sulfur dioxide can also enter the stratosphere along with the ash. It binds with water, creating tiny sulfuric acid droplets, which reflect some of the solar radiation back into space. The droplets are so small, it takes years for them to fall from the atmosphere. This is what happened when Mount Tambora in Indonesia erupted. The consequences of its eruption in 1815 are considered the most catastrophic in modern times. "10,000 people were killed directly by the lava. For weeks, the skies rained ash. Hundreds of kilometers away, houses collapsed under the weight." The tiny sulfuric acid droplets dispersed the red component of the light, creating breathtaking twilights all over the world. In the summer of 1815, magical colors in the sky influenced William Turner. But what looked so enchanting soon developed into a global disaster. A cloud of ash, dust, and sulfuric acid aerosols circled the Earth. The cold and resulting crop failures led to the worst famine of the 19th century in North America and Europe. This brought far-reaching demographic, economic, and political changes. But the smokestacks that bring death and destruction here are elsewhere a creative source: black smokers. These deep-sea chimneys were first discovered only 30 years ago. Up above, the heavy metals they discharge would be frowned upon. But here below, chemicals from the Earth's interior provide the basis for life. It is a unique ecological community independent of sunlight, oases of living organisms in an inhospitable environment. For millions of years, our world has been taking shape from here, deep in the ocean's depths. And it was volcanoes that once freed our planet from an icy embrace. 700 million years ago, the whole Earth was clutched in the numbing grasp of a kilometer-thick sheet of ice. Only deep in her interior was magma able to push its way outward. Like a giant steam boiler, the pressure within was rising until the heat finally found its way out. But it wasn't the lava masses that liberated the planet from the icy grasp. It was huge amounts of CO2 hurtled by the volcanoes into the air, which then collected in the atmosphere, causing the Earth to warm up. Without the fire-spitting mountains, our Earth would probably still be a giant snowball in space. We would have no chance of survival. We wouldn't even exist. Mount Erebus in Antarctica also bears witness to the very origins of our world. The volcano is 1 million years old. It shows researchers more than just how volcanoes work, what fuels them, and what provokes them to erupt. Deep within, the volcano also reveals compelling traces of life that come as a complete surprise. An expensive network of ice caverns has developed here. Scientists take laser measurements to gain deeper insight into their origins and the dynamics of their growth. Because from year to year, the caves change shape. A large part of the gases reaches the surface via the lava lake. But the high concentration of gas in the ice reveals that heat and gases from the magma also find other ways of escaping from the depths. The labyrinth of passages, caves, and chimneys apparently represents the exhaust system of the volcano. What the researchers have discovered down here are bacteria and fungi from the time of the volcano's inception. Sediments of volcanic ash on the walls, together with warm, humid air, appear to offer an adequate environment for sustaining life. It is also highly possible that these life forms will one day provide the key to new medication.
A truly extraordinary feature of Erebus are the ice caves, which are like an Alice in Wonderland world under the ground. And we're interested in them volcanologically because they are a manifestation of the heat and gas emission from the volcano. And we'd like to know how they compare with what's coming out of the lava lake in terms of gas emissions. But they're also very interesting because they're full of microorganisms, extremophiles, and it's very possible that some of those organisms are metabolizing some of the volcanic gases that are leaking out.
In their search for life in the ice of Mount Erebus, the scientists are combing the archives of long-forgotten epochs of our Earth's history. The discoveries here could add fuel to the ongoing heated debate about the origin of life. A few thousand kilometers to the northeast lies Hawaii. The chain of islands in the middle of the Pacific floats above a hot spot. Here, the especially hot molten mass cuts like a blowtorch through the Earth's crust. While the red-hot source below remains stationary, the Pacific plate above continuously moves along, constantly bringing new volcanic islands into being. Here we find the world's most active volcano, the Kilauea. It expels the most magma by far, but is not explosive, and as such, not especially dangerous. The lava flows down the cliffs, transforming entire regions of the island into outsized knitting patterns. Thanks to the constant lava flow, the island continues to grow. Way up in the clouds, the Mauna Kea. Although it rises to an altitude of only 4,200 meters above sea level, measured from its foot deep down in the Pacific, the extinct volcano is 10,000 meters high, making it the world's tallest mountain. The fate of the island chain, however, has long been sealed. The Pacific plate is racing at the astonishing speed of 8 to 10 centimeters a year, almost 10 times faster than others, towards the world's biggest crematorium, Kamchatka. Here, the Hawaiian Islands are melting. One section rises up beyond the subduction zone and is spit out again by Kamchatka's volcanoes. In geological terms, the approximately 2 million year old peninsula is an infant, and a very lively one. Of the 160 volcanoes here, 28 are still active. Nowhere else on Earth is there such a dense cluster. But what will happen next? Where will the next volcano eruption occur? How suddenly and how powerfully? Climate change and rising sea levels are thought to have an effect on volcanic activity. That doesn't make it any easier for scientists to forecast events. But what are such predictions actually worth anyway? It's always been difficult to predict a volcanic eruption, but since May 2008, it has become seemingly impossible. The Chilean volcano Chaitén, considered extinct for centuries, made a sudden, virtually unannounced comeback in the form of a massive eruption. The inhabitants of the village of the same name just managed to bring themselves to safety before the eruption column collapsed, and a pyroclastic flow sped into the valley at a speed of several hundred kilometers per hour, laying waste to the village. American volcanologist Jonathan Castro visited Chaitén shortly thereafter to find out why a volcano long thought extinct could erupt again so suddenly. When the magma rises upwards towards eruption, it causes earthquakes. As it travels further upwards, crystals develop within it. Their growth structures show the speed at which they have shot up the volcano. Despite the constant spitting of the volcano, Castro climbs as high up as possible to get the best samples. Back home in his laboratory at the University of Mainz, the volcanologist tries to reproduce the natural pumice from Chaitén. To this end, he seals the pulverized stone mixed with water in a heat-resistant golden capsule. The capsule is then put in a pressure cylinder and heated in an oven to a temperature of over 800 degrees Celsius and put under pressure. Under these conditions, growths in the form of the tips of crystals build up around the feldspar embedded in the pumice. If he succeeds in reproducing the crystals in the pumice, it will mean that he is able to create the conditions under which they grew within the volcano. An experiment with the oven door open shows what happens to the pumice stone during its journey upwards. The water it contains vaporizes, creating gases that cause the pumice to grow. When the temperature gets too high, it causes an explosion. The volcano erupts. Pressure and temperature undergo constant variation. Extreme magnification under the scanning electron microscope will show whether Castro has succeeded in simulating the conditions of the eruption. And he does, in fact, discover identical forms. The experiment is a success, but the result is beyond disconcerting.
So, one of the discoveries here today is the formation of these perfect crystal faces, which in turn tell us that the magma must have moved up through the conduit to the surface at least 1 meter per second. That's a little bit slower than our walking pace, but if a magma is coming from very deep in the earth and it's traveling at that speed, that means we only have a few hours to prepare ourselves for a very explosive eruption. the experiment may also tell us some bad news. In particular, we see many volcanoes like Chaitan around the world, suggesting that eruptions at those volcanoes can also develop very quickly. However, in contrast to Chaitan, these other volcanoes can be populated by many tens of thousands, if not millions of people. So, if an eruption that develops very quickly happens at one of these other volcanoes, it's highly unlikely all of those people will be organized to get out of the way.
Volcanic eruptions, almost without warning. A prospect that doesn't exactly make the world seem a safer place. But sufficient warning time will become increasingly important in the future because volcanic activity appears to be increasing. Since the start of the last warming period, volcanic activity has increased 10 to 30-fold from Ice Age levels. Researchers thus conclude that climatic warming will encourage the activity of glacial volcanoes. With the associated rise in sea levels, it will also influence coastal and undersea volcanoes. That also applies to the Mediterranean and the volcanic island Stromboli. The constantly spouting volcano makes this site a popular open-air laboratory for volcanologists because the answers to fundamental questions about volcanic eruptions remain inconclusive or have not yet even been found. In the fall of 2012, an international team of experts led by Italian volcanologist Jacopo Tadiucci arrived on the island to test a new research approach. To understand how volcanic particles are expelled, the precise process, time period, and expense of energy involved, it is necessary to measure what is called the exit velocity. Everything of concern here takes place deep within the volcano and cannot be observed directly. So the researchers have to make the most of what the volcano does present to them. High-speed cameras are a prevalent technology, but they have never before been deployed to probe a volcano. The very first try was a total success.
We discovered that volcanic particles can be erupted by this very, very small explosive eruption at an unsuspectedly high exit velocity. So they can reach velocities supersonic up to 400 meters per second. One thing that it tells is that we don't know all that we should know about the volcanoes. And so with new techniques, there is still room for increased discoveries.
By determining the exit velocity of the particles, the researchers can also calculate how far they fly and then make a projection for major eruptions. A thermal imaging camera fills in another piece of the puzzle. But the scientists here are also shown that they still don't know many things they should. Mount Vesuvius in the Gulf of Naples is the only active volcano in mainland Europe, and it makes even hard-boiled volcanologists and disaster researchers break out in a cold sweat. The view of the city from the crater's edge gives a very clear picture of the danger Naples would face in an eruption. Volcanologist Giuseppe Mastrolorenzo never tires of sounding the alarm bell to warn of imminent danger. Vesuvius is a stratovolcano like Chaitan and is monitored 24/7. And still, what happened in Chile can happen here too. But if an eruption on the scale of the one in 79 AD, or even the much worse ones in the Bronze Age, were to hit now, the current emergency evacuation plans wouldn't be worth the paper they're printed on.
The present emergency plan considered that just the people living in the 18 towns and villages around Vesuvius must be evacuated before the eruption. So all the people living around the crater within a distance in the order of, in average, 8 kilometers from the crater. But according to our research, we have revealed that pyroclastic surges and flows can reach distance even exceeding 20 kilometers from the craters. So all the people living in Naples must be evacuated before the eruption.
Images of a relatively small eruption in 1944 give an impression of the destructive power of the Colossus. Burdened by the weight of the hot molten mass and ash, sturdy buildings crumble. The people could only look on helplessly as their homes were consumed in flames. As so often in such circumstances, all that remained for the survivors was their faith. It is there they turned for salvation and protection from further eruptions. The people whose skeletons were discovered in a boathouse in Herculaneum apparently had no time for prayer. Archaeologist Pier Paolo Petrone examined these bones and determined that an ash cloud as hot as 500 degrees Celsius had claimed the victims. Within seconds, their flesh had vaporized, and the subsequent cooling and hardening of the ash left them frozen in their last living positions.
So now we know that at Herculaneum, so at a distance of 6 kilometers from the volcano, but even as far as Pompeii, 10 kilometers, there is no chance to survive for the resident population living around Vesuvius, even if the people is sheltering within buildings. So they can survive to the direct impact, mechanical impact of the surge, but they will die due to the very high temperatures.
The likely fate of Naples and its residents when Vesuvius once again blows her top can be clearly observed in the Caribbean. 1995 marked the start of the series of outbursts at the Soufrière Hills volcano on the island of Montserrat. The capital, Plymouth, was evacuated within 2 hours. The inhabitants were able to escape with their bare lives. It is still too dangerous to return there. Here, buried beneath the ash, lies a moment that dates back over 15 years. Such a sudden evacuation is inconceivable in the crowded, narrow streets of Naples. And the Neapolitans are fatalists. Aware of the dangers of the volcano, they still live with a "what will be" attitude, not allowing themselves to face the inevitable head-on. But it will happen eventually. Once the eruption column has collapsed under its own weight, pyroclastic flows are sent racing down the slope at over 300 kilometers per hour. Within 5 minutes, Naples would be almost totally annihilated. Such an eruption would leave 3 million people without a chance of survival. But few people know that Vesuvius grew out of the remains of a supervolcano that spans the Bay of Naples, the Campi Flegrei. The last major eruption 39,000 years ago caused the Earth's crust to collapse, leaving behind a crater known as a caldera, and the mighty giant is active. The ground under the city of Pozzuoli has repeatedly been jacked up. Tens of thousands of people have been evacuated from the city several times in the past, when houses in the old town had begun to shudder and crack. But as soon as the crisis was over and the ground had calmed down, they all returned as if nothing had happened. But the danger remains unabated until today. Just a stone's throw away from Pozzuoli, the supervolcano lets off steam at several different points. For volcanologists, a fumarole is like an open window into the caldera. Over the last 10 years, volcanic activity and gas concentrations have continuously intensified, and the ground deformation has also grown. The clock is ticking.
This is a super volcano, and there is a possibility also in the future that a new large-scale eruption may occur in a very densely populated area.
When it erupted 39,000 years ago, it expelled 80 times more magma than Vesuvius did in the year 79 AD. Ash was distributed over the entire eastern Mediterranean region, over present-day Bulgaria and the Black Sea, all the way to Russia. If it happens again, it won't only be a problem for Naples and Italy. We will all disappear in darkness. In the next episode, we look at earthquakes. In February 2010, a magnitude 8.8 quake hit off the coast of Chile. The city of Concepcion was almost totally destroyed. In the spring of 2012, a scientific research team traveled to the Andes to find evidence of the earthquake's influence on the Chillán volcano, and thus establish a completely new correlation between earthquakes and volcanoes. Join us again.